All right, so using imaginary root theorem, let me reread it again. It was over here. We know that if one of the binomials with an I, so I represents here an imaginary number, if that binomial is an x-intercept or a root of a polynomial, then its conjugate will also be a root. They come in pairs. So let's use that on this question. So we're told it's degree 4. So one of the zeros is that one. So obviously 1 plus 2i will also be part of its zeros, right? And then this also gives you 1 minus I. So we have 4 x-intercepts here that are told to us. Only 2 were told to us, but technically those other 2 just come from the fact that they come in pairs. Can I have Renuka say hello?
Hi.
Hello, Renuka. Do you remember when we did factored form, we had with quadratics x minus r and then x minus t for quadratic?
Yes.
What we're going to do is just extend it so that we have 4 terms. So I'll call it r1, r2, x minus r3 for root 3, x minus root 4. So each one of these roots are up here already. So let's start writing it in. Keep the a. What about x minus, what's the first root do you want to use, Renuka?
1 minus 2i.
Okay, make sure that you guys put an extra parentheses around it because that negative will distribute eventually. Let's continue on x minus another one.
1 plus i.
Let's do the conjugate first side by side because there will be something neat that we can do right away with it. Okay, so are you okay if I put 2i first?
Yeah.
Okay, next one down, x minus.
1 plus I, and then x minus 1 minus I.
Yeah. All right. So before you're going to finish this question off by using the point to find what a is, remember our polynomial should actually have rational coefficients. So everything about this should be rational, but right now it's not. We have imaginary numbers all over the place. So I forget when we did this. I think, let me just quickly go through the notes. We did at one point find new families. Families was probably topic 4. Yes, over here. Do you remember what we did a few days back where we had not imaginary numbers, we had irrational numbers that we could completely just expand, and we did this long way over here, term by term, we expanded, collected like terms and so on. But then I showed you how you can think about it as a difference of squares. Are you guys going to be okay if I apply this difference of squares method for our complex ones? Let's start there, and then you can just clarify if something gets lost, okay, Renuka? And everybody?
Okay.
So start off by removing the inner brackets first. So we'll have x minus 1, oops, plus 2i. Do you agree?
Yes.
And the second bracket would be x minus, you tell me.
X minus 1 minus 2i.
And then the third bracket, x minus
1 minus I.
And lastly, x minus 1 and
plus I.
Plus I. Okay. So I'm going to highlight some things that will help us to do this difference of squares, okay? Watch this. This x minus 1 and this x minus 1, think about it as if it's one entity, okay? And then we have plus 2i. Oh, I want a different color. Plus 2i minus 2i. Do you agree that that's kind of like a plus b and a minus b here?
Yes.
And if we were to FOIL a plus b, a minus b, don't we get a squared minus b squared? Yes or no?
Yes.
Okay, so let's concentrate on, oops, give me a chance to switch. Y equals a. So the first binomial will be a squared. So that's the yellow thing squared. So what would that be?
X minus 1 squared.
Yeah, we'll deal with that later. And then minus b squared. For us, minus b squared would be something with a square. What do I put inside?
2i.
2i. So we'll deal with that later. Let's do the same thing with the other one. Can you do that without me highlighting anything?
So it would be x minus 1 squared minus I squared.
I with a square. Good job. Anyone lost? Okay, so now we're going to clean things up. Please remember that I squared actually was equal to something. Renuka, do you happen to remember?
-1.
It was -1. So this would be minus a -1 here. And this will be x squared minus 2x plus 1. Is this okay, or is that too fast when I expanded this one to this?
No, it's fine.
That's okay. All right, let's do the same thing here. Renuka, you tell me.
So it would be x squared minus 2x plus 1 minus minus 2.
It would be 2 times 2 is 4.
Oh, 2 times 4, and then it would be -1 inside.
-1 inside. Okay, so we just need to clean up a little bit more because we have some like terms to combine. This is positive 4 plus 1. What does that give us?
Positive 4 plus 1 is 5.
Right. And then this particular one, what would be here? X squared minus 2x and what else?
Plus 2.
Good. All right, now that we have this, and it's nice and compact without the complex numbers, then we'll actually find this a using the point provided. So now we're going to sub.
Miss K.
Yes. Did I mess up?
In the first bracket, wouldn't it have been minus 2x? Like
This
in
one
the
over here? Yes,
yeah.
It would be minus. Julian, point. Thank you. All right, so Renuka, back to you. What do I replace instead of y here?
Y would be 20, and all the x's will be 0.
Okay, so let's continue on from here. We will have 5 and 2 multiplied together. What's a then?
A is 2.
And so you would just rewrite your equation. Therefore, the polynomial will be 2, and then keep these not expanded unless you feel like expanding it, but you don't have to. So the whole point is to make sure that you have rational coefficients. So let's reread our question. Did we finish everything? It says find the unique polynomial. So it's not a family because we actually know everything about it. So that it's a degree 4. So yes, it will be degree 4 because square times square would be power 4. And these will actually have these particular x-intercepts. Just like I did before, just very briefly want to tie again to you. So if I asked you for the zeros of this one, Renuka, do you recall quadratic formula?
Quadratic form is -b plus minus square root of b squared minus 4ac all over 2a.
So if you were to perform this, you would have negative of -2, so that's like plus 2. Then you'd have -2 with a square minus 4 times, you tell me.
Minus 4 times 1 times 2.
All over 2 times 1, correct?
Yeah.
So what would happen over here is that you'll have 4 subtract 8. What's 4 subtract 8, Renuka?
-4.
And then you would say, well, square root of 4 and square root of -1 could be separated out like that. And so that would be plus or minus 2 with an I all over 2, which actually gives you exactly one of the 2 pairs that we were talking about. So the reason why I did that for you, so that you understand why do they come in pairs, because it's coming from the quadratic formula, which always has plus and minus in the middle. Is this part okay with everyone?
Yes.
All right. And then one more. So if you see X element and then the C here, just means it's complex numbers. So it doesn't have to be just real numbers. Let's go with who else haven't called on in a while. AP students. Let's see. I have a list. I'll keep track. Alex, last time your mic was giving feedback. Let's try it again today. Would it work? Say hello, Alex. Hi, Alex.
Hey.
So we have this polynomial that says solve. Solving an equation means we want to find all the solutions, x equals, and we're going to have how many here, possibly?
We're possibly going to have 3.
Yes. Okay. In order to solve this, we need to have 0 on one side.
Yeah, okay, so let's subtract 60.
Okay. Now what, Alex?
Well, there's multiple ways we can go about this. I kind of want to do the, what's it called? The remainder theorem, the one where you put all the numbers, all the sets of possible numbers divided by all the sets of possible numbers it could be.
Yeah, before you go there, let's double check if factoring by grouping will make it faster, because if it works, then we don't have to do the synthetic division.
Sure.
You recall in grade 10, we did grouping first 2, finding what's common, grouping the second 2, finding what's common. And if the bracket ends up being identical, then we can simplify so much work for ourselves, right?
Yeah. Okay, let's try that first then.
Yeah, let's try. So what can we pull out of these two?
5x squared.
Okay, what's left?
X minus 3.
Okay, what can we pull out of these two?
Just 20.
And what's left?
X minus 3. Okay.
Right? So isn't it?
Yeah.
Remember this? Then it just makes it a lot easier, so you don't have to do the whole rational root theorem. Synthetic division, all of that is out the door. Okay.
You're right.
So let's write down x minus 3 and what?
5x squared plus 20.
Okay. I want to find all my solutions of x. So obviously one of them, so therefore solution x equals 3 is one of them. What about this one?
This one we can apply quadratic formula to find out the roots, and then we can factor that way.
Yes, or because x appears only in one spot, I could use property of 0.
Oh, you could, yeah.
And just solve.
Mm-hmm.
Okay, you talk me through it. What happens?
Okay, so subtract 20 from each side first. Yeah, then divide by 5.
Okay.
And of course, square root. Both sides.
There's plus and minus, square root of 4 and square root of 1, negative 1, sorry.
So just plus or minus 2i.
So minus 2i. And so that's your two solutions right here.
Mm-hmm.
Easy?
Yeah.
Nice. Any questions from anyone in the class? All right, so your thing would be also to factor and find all the complex solutions of this polynomial if it was equal to 0. Remember, real numbers are also part of complex numbers. So you could say that this is a complex number too, because 3 plus 0i could be recorded in that complex way, right? So if there's no questions, I will stop the recording.